Everyone says RAG fixes LLM hallucinations. But after building and deploying these systems, I can tell you that narrative misses a crucial, frustrating truth. RAG often introduces its own set of critical, hidden flaws that are far harder to diagnose than a simple hallucination. If you're relying on RAG for accuracy, you need to know these 3 specific weaknesses, because they could be subtly undermining every single AI output you generate. Let's peel back the layers. At its heart, Retrieval Augmented Generation, RAG, sounds wonderfully simple. Imagine it like this. You're a customer asking for a perfect, authentic Coke oven. The chef, our powerful large language model, knows how to cook, but needs the exact recipe. That's where RAG steps in. The kitchen's brain, the LLM, points to its comprehensive library of cookbooks, our knowledge base. Then, a diligent sous chef, representing the retriever component, quickly and precisely finds the one, perfect, authentic Coke oven recipe from countless others. They hand it to the chef, who, armed with the precise instructions, prepares your dish flawlessly. This is the promise, a reliable, grounded process, free from the guesswork of a chef trying to remember a recipe from memory. No more hallucinations, right? Just clear instructions, accurate execution, and a perfect outcome. But here's where the narrative of RAG's perfection starts to crumble. The promise of automatically grounding LLMs in authoritative data often falls short, leading to new, unexpected failure points. Many mistakenly assume RAG is a set-it-and-forget-it solution, a magic bullet that reliably eliminates hallucinations. But the reality for early adopters is far more frustrating. While RAG can dramatically improve accuracy, its implementation is anything but straightforward. It introduces a fresh set of complexities, ongoing challenges that are less about bad data and more about how the system actually functions. It's like a chronic condition that requires continuous management. We're about to expose the 3 critical flaws nobody tells you about, the ones that lead to subtle but significant inaccuracies, even when everything seems to be working. The first critical flaw stems from retrieval quality. What happens if our diligent sous chef, the retriever, gets confused? This isn't about bad data in the library. It's about the sous chef grabbing the wrong book, even if the right one is right next to it. You asked for authentic Coke oven, but the sous chef, perhaps too focused on keywords or flashy covers, pulls out quick chicken stir-fry. Or worse, maybe they see Coke oven for dogs and miss the crucial context. The information exists in our knowledge base, but the retriever component misjudges relevance, pulling something superficially similar but fundamentally incorrect or incomplete. This directly undermines the output. The LLM then receives irrelevant context, leaving it confused, trying to make sense of a stir-fry recipe with Coke oven ingredients. This isn't a hallucination. It's a misinformed generation, and it's far more common than you'd think. Even if the sous chef nails the retrieval, our second critical flaw emerges, the confused chef. This happens when the LLM, despite having the correct recipe, struggles to semantically understand or interpret the instructions accurately. It's not about missing data. It's about misreading the nuances. Imagine the recipe clearly states, reduce red wine by half, but a nearby paragraph discusses adding chicken broth. The chef, our LLM, might get the sequence wrong, pouring a whole bottle of unreduced wine in after the broth. Or, despite seeing red wine, they might grab a bottle of white wine, a subtle semantic misstep based on prior biases or a momentary lapse in contextual awareness. This isn't hallucination. It's subtle misinterpretation, leading to a fundamentally flawed dish, even with perfect ingredients. The LLM fails to synthesize the information coherently, leading to inaccuracies that are incredibly difficult to debug because the source material was correct. Finally, even if our sous chef retrieves perfectly and the chef understands each individual instruction, we face the third critical flaw, integration complexity. This is where the overall orchestration of the RAG system breaks down, even if its individual parts seem to work. Imagine the chef, following each step correctly, but then their phone rings, pulling their attention to some irrelevant memory. Or they get an instinct to take a shortcut, combining steps or ingredients in a way that the recipe doesn't intend. Perhaps searing chicken and adding vegetables are done in the wrong order due to an attempt at efficiency, leading to a soggy, unappetizing mess. The LLM struggles to properly integrate the retrieved information with its own internal knowledge, leading to a response that, while containing correct facts, is poorly structured, lacks coherent flow, or subtly misrepresents the overall context. The result is a dish that looks like coq au vin, but tastes entirely wrong. This isn't just about data or interpretation. It's about the entire system's ability to coordinate, a complex challenge in building robust AI. This cumulative effect of these three flaws, a misguided retriever, a confused interpreter, and an uncoordinated system, leads to the true cost, hidden spoilage. It's why early adopters are facing unexpected RAG failures and significant frustration. It's not always obvious, glaring hallucinations, but rather subtle, persistent inaccuracies. Imagine a dish that looks like coq au vin, smells like it, but tastes just wrong. It's palatable enough that you might not immediately call it a complete failure, but it's far from perfect. It's the stir-fry noodles mixed into the coq au vin. These subtle but significant inaccuracies chip away at user trust, making your AI outputs unreliable and turning what promised to be a seamless solution into an operational headache. This is why RAG is not a simple fix, but an ongoing crisis, a complex system requiring constant vigilance. So what's the path beyond these hidden flaws? It's not simple, but it is achievable. Addressing these challenges requires deep architectural thinking and advanced solutions, moving far beyond surface-level fixes. For retrieval quality, we need advanced techniques like re-ranking, where multiple models refine the sous chef's initial selection, or leveraging knowledge graphs for richer contextual search. To combat semantic understanding issues, we employ contextual refinement and precise LLM alignment, fine-tuning how the chef interprets instructions, sometimes even using smaller, specialized models for specific tasks. And for integration complexity, the solution lies in robust architectural patterns, sophisticated prompt engineering, and comprehensive observability to monitor the entire cooking process. The RAG illusion disappears when we bring intention and intelligence to every step. It's about mastering the culinary AI, not just deploying it. This is where true RAG mastery begins. Want to truly master RAG and build resilient AI systems? Subscribe to our channel for advanced insights, practical strategies, and deep dives into overcoming these critical challenges. Don't let your RAG systems secretly undermine your trust.